Dear students, today we'll be going to see another interesting topic, which is viscosity. So you people have already heard about the friction in your lower classes, right? Okay, what you mean by this friction actually? When two objects starts to slide on each other, there exists a force which opposes the movement of these two objects with each other. Correct, right? So ಇದು ಮೂವ್ ಆಗಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡುವಾಗ ಏನಾಗುತ್ತೆ, the bottom surface is going to oppose a force which is in the opposite direction. Correct? Same friction which helps us to walk on the floor. See, when we move forward, we actually apply a force on the forward direction, but there actually a force which is acting in the opposite direction on our foot, which actually balances us not to slip on the floor. Okay. Similarly, the friction on liquids is known to be viscosity. So where this viscosity actually exists? This exists when two or we can say like when something starts to move inside the liquid. Okay, so what actually happens? The object is going to experience some force in the upward direction. So this actual force acts between the layers of the liquid. Okay, so I'll explain the clear idea about this viscosity. So the definition says that it is a force that opposes the relative motion between the layers of the liquid. So you know, right, liquid will have different layers. Like we can, if you consider water flowing inside a pipe, so different layers of water will be flowing like this. Correct? Now there is a force between these two layers or these two layers. Okay, that force between the layers of the liquid is known as viscosity. Okay, so we will do a small illustration over here. What we are going to do is we will take two glass plates. Okay, in between the glass plate we will fill it with some liquid. So let's fill with oil. Okay, for the first time when we do this illustration, we will fill it with the oil. Now you just try to slide the upper glass on the surface of the lower glass, which is filled in between the oil. Now what is going to happen? You will understand like the top part of the liquid is going to move freely, but what about the bottom part of the liquid? It will be stuck to the lower glass, right? Correct? So liquid and fill ಮಾಡಿ ನಾವು move ಮಾಡ್ತಾ ಹೋದಾಗೆ what actually happens? The upper glass moves very freely, but what about the lower part of the liquid? Liquid which is in contact with the upper part moves with velocity v if the glass moves with velocity v, but what about the lower part? Here, see, this is the glass. Okay, and this is actually the liquid layer up from here to here. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ನಾವು liquid layer ಅದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದಾಗಿ ಮಾಡಿದ್ದೇನೆ. ಓಕೆ, ಮ್ಯಾಗ್ನಿಫೈ ಮಾಡಿ ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ ಇಲ್ಲಿ. Now this is actually the liquid. Okay, up to here. Now this glass is going to be slided over this glass. Now you people have already seen about shearing stress, right? What about shearing stress? We apply like this. See, a body is taken like this. When we apply force only on the top, what actually happens? It displaces like this, right? Similarly, what actually happens over here is the upper part of the liquid moves like this with the velocity v nearly equal. As we go down to the bottom part, we see that liquid velocity decreases, and finally whatever liquid in contact with the lower surface will be stationary. So whatever liquid which is in contact with the lower layer will be stationary. So we will consider a pipe over here. This is the pipe. Okay, so you can consider the pipe, and this is the upper part of the pipe, this is the lower part of the pipe. Now if you people put water to the garden, and if you observe the pipe, you can clearly see that as the if you hold it like this, okay, you see that water at the middle will have more velocity compared to the water which is flowing out on the sides. Now you see here, this part of the water is actually in contact with this side, and this part is also in contact with this side. Now what actually happens here, as we move towards the pipe, okay, over here, velocity of the liquid decreases, and as we move to the center, velocity of the liquid increases. Now here what actually happens is, these layers, okay, are going to help the middle layer to move faster. Okay, such type of flow is known as laminar flow. We will see that laminar flow first. It is a type of flow of liquid in which the upper layer pulls it forward while lower layer pulls backward, which results in a force between the layers. Now see, if water is flowing in this one, what actually happens, you can consider this is upper layer, this is also upper layer. Okay, idan eradanu kuda upper layer anta consider madbodalva. This is lower layer. See why? Because if you just turn it, this will become upper layer, right? So this is actually lower layer, this is upper layer. Now what does this upper layer do? Upper layer pulls it forward. See, upper layer pulls it forward while lower layer pulls it backward. That is the reason why there is a force developed between the layers. Okay, ಇಲ್ಲಿ ನೋಡಿ, velocity decreases as we move towards the pipe. Okay, similarly here also, as we move towards a pipe, velocity decreases. It will be clear over here. See, this line actually shows the magnitude of velocity. Velocity is, say, if you take it from this point, see, magnitude is maximum, decreases, decreases, decreases. Correct, right? So what actually happens here, as we move towards a pipe, velocity decreases. These layers actually helping these layers to move forward. Okay, ಈ layers ಇದೆಯಲ್ವಾ, ಅದು ಈ middle layer ಅನ್ನು forward move ಆಗಲಿಕ್ಕೆ help ಮಾಡ್ತಾ ಇದೆ. So what actually happens, this layer will have maximum velocity while these layers will have minimum velocity. Okay, so such type of flow is known as laminar flow. Okay, now we'll come back in this idea. Okay, if you replace this oil by some honey, okay, if you replace this oil by honey, what is going to observe? Will be the velocity same for both the cases? No, right? Velocity in the case of honey will be less than that of the velocity in the case of oil. So we say that honey is more viscous than oil. Okay, then this is the idea about viscosity. Now we will see something about coefficient of viscosity. Okay, the mathematical idea of this one. It is actually the ratio of shearing stress to strain rate. So we observe that this viscosity actually depends on two factors, that is shearing stress and strain rate. So we can write it over here, that is F divided by A, that is nothing but shearing stress, divided by strain rate, that is V by L. So these things were discussed in the previous chapter. Okay, now what we can do is, we can take this A to the denominator, L will go to the numerator, we will remain over here. Okay, so this coefficient of viscosity is known as eta. Remember this equation. SI unit is nothing but Poiseuille. Okay, so this SI unit is given after the honor of scientist called Poiseuille. So coefficient of viscosity unit is nothing but Poiseuille. Other units which you can mention over here are Newton second per meter square or Pascal second. Okay, so this is also other units of viscosity, coefficient of viscosity. Now what about dimension? Dimensional formula you can write m L to the power minus 1 and T to the power minus 1. Now, what about this viscosity of liquids and viscosity of air, or we call it as air resistance? So, this viscosity of liquids decreases with increase in temperature. If you increase the temperature, viscosity actually decreases, and in the case of air, if you increase the temperature, viscosity is going to get increased. So, this is the basic idea of viscosity. So, you need to read your textbook for the clear idea. Okay. So, notes you can just write this one, and this question may be asked for 1 or 2 marks. That's it. Okay. Next thing what we are going to see is about Stokes' law. So, you have got the idea about viscosity, okay, and how viscosity varies for liquids and air or gases in terms of temperature. That also we have studied. Now, we will see the Stokes' law. Stokes' law actually tells you, okay, in the case when an object, okay, let me consider this chalk, when it falls through this air, okay, or any liquid. So, generally we are considering fluid. So, fluids are nothing but it can be either liquid or gases. So, when an object falls through the fluid, okay, it is going to experience a force in the opposite direction. Correct? We have studied viscosity, correct, right? There will be a force which is acting in the opposite direction. Now, this Stokes' law says that when the velocity of the object is more, okay, the force experience will also be more. That means force experienced by an object moving through a liquid or a gas, the force experience will be directly proportional to its velocity. That means if it is moving with a higher velocity, it will experience more force in the opposite direction. Now, you people must have heard in your lower classes, maybe your teachers must have told you, like when an object is dropped from some very high distance, it will move very fast due to gravity, it will move down, correct? It will move continuously, and after some time, it is going to attain a constant velocity. It is not going to accelerate. If you people have heard about it, then it is due to the concept of viscosity. That is explained by Stokes' law. We will see the definition or the statement. Viscous force is proportional to the velocity of the object and it is opposite to the direction of motion. Now, if an object is falling like this, the viscous force is acting in the opposite direction, okay, and it is actually proportional to velocity. So, it is proportional to the velocity. Now, on which all other factors does this force depends? We can write over here, F is equal to 6 pi r eta and V. So, what is this r actually? It is radius of sphere or the any object which is falling, okay, radius of that. Then eta is nothing but viscosity, V is nothing but terminal velocity. Now, I will tell you the terminal. You people can understand the same idea, not just the falling of an object in the liquid or gas, not that. You can also consider the simple pendulum. So, you people have seen this pendulum, right? It will be moving like this, okay. Finally, it stops at particular time. Why it stops actually? Because there is a resistance of air which actually opposes the movement of that pendulum through this air. So, you will have an experiment called simple pendulum where you can understand it much better, okay. For the time being, just understand when the pendulum moves through this air is going to oppose some force on that. That's the reason why finally it is going to stop at a particular point, that is the equilibrium point. Now, here also you can understand when this object falls, there will be two types of forces which is acting upward and only one type of force which is acting downward. What is the force which is acting downward? Obviously gravity, right? And there are two types of forces, one is viscous force, another one is a buoyant force, okay, buoyancy force which will be acting upward. It is a force between this solid material and the fluid. Force between, buoyancy force is the force between the solid surface and the liquid surface. Similarly, what is viscous force? Force between the layers of the fluid. So these two forces will be acting upward and gravity will be acting downward. Now you can understand, as velocity increases, what happens? Opposite force also increases. So at a particular point, maybe anywhere, these two forces become equal. Then what actually happens? When the forces become equal, then the object is not going to stop. Object stop agudilla, then what happens? Acceleration becomes 0. Then the object is going to move down with the constant velocity. So that particular velocity is known as terminal velocity. Velocity of an object in equilibrium. Okay, that is known as terminal velocity. Now we can write it over here. So this is nothing but the force, okay, that is the viscous force, okay, whatever experienced over here. Now this is nothing but the equilibrium force, which is on the sphere, okay, and these two forces are equal in equilibrium state. Now you can understand this is the dimension of force, here also dimension of force. Why? Because you see here, this is nothing but volume of the sphere, 4 pi by 3 r cube or a cube. We can write it as r cube. As I mentioned there r, we'll write it as r only. No issues, okay. A or r, both you can write. But you have to mention it, that's it. So it is 4 pi by 3 r cube. It's a volume, okay. This is rho and sigma. Rho and sigma are nothing but mass density of the sphere, okay, mass density of sphere and mass density of fluid. Now you see here, this is volume, this is density, this is acceleration due to gravity, right? So what happens? Here density means mass by volume. So this volume will get cancelled, and mass into acceleration is nothing but force. So this term also carries the dimension of force. Check ಮಾಡಬಹುದು ನಿಮಗೆ ಫಸ್ಟ್ ಯೂನಿಟ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಲ್ವಾ, how to check the dimension of an equation. ಅದನ್ನು ಚೆಕ್ ಮಾಡಿ, you will get the dimension of force. Here also dimension of force. Now how we can write the equation for terminal velocity? Take all the terms to the other side. ಈ ಕಡೆ ತಗೊಂಡು ಹೋಗಿ terms ಅನ್ನಲ್ಲ. Then what do you get? ಇದು ನೀವು ಮಾಡಬೇಕು. Actually you should do it by yourself and check whether you are getting this final equation. That is Vt is equal to 2r square rho minus sigma into g divided by 9 eta. Then check ಮಾಡಬೇಕು ಬರ್ತಾ ಇದೆ ಅಂತ equations, okay. Now you can see here terminal velocity depends on a square or r square, actually we'll write. It depends on, what is it? It is the, what is r actually? Radius of the sphere, right? And inversely on the viscosity. So inversely on the viscosity. Now I'll make it very clear. Terminal velocity depends on these two factors. That means if the viscosity of the medium is more, then terminal velocity will be less. If the radius of the sphere is more, then terminal velocity will be more. Correct, right? So if r is higher, Vt is higher. If eta is higher, then Vt is smaller. Okay, so this is the idea about this Stokes law. Now we will see one more thing, that is about Reynolds number. So this is a very simple concept. Reynolds number is actually a dimensionless number. Okay, dimension illadanta one number that actually tells you whether the flow is either laminar or streamline, or it is unsteady, or it is turbulent. So flow ಯಾವ ಟೈಪ್ ಇದೆ ಅಂತ ಚೆಕ್ ಮಾಡುವಂತ ಒಂದು dimensionless number, that is known as Reynolds number. Okay, so we'll see that. It is a dimensionless number whose value gives an approximate idea whether the flow would be turbulent. ನಿಮಗೆ ಇದು ಬರೆದ್ರೆ ಸಾಕು ಡೆಫಿನೇಷನ್. ನಿಮಗೆ ಇಫ್ ಯು ಆರ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ 1 mark, ಓಕೆ, 1 mark ಕೇಳಿದ್ರೆ ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು. ಸೊ ಯು ಹ್ಯಾವ್ ಅನ್ ಇಕ್ವೇಷನ್ ಫಾರ್ ದ್ಯಾಟ್. ಸಿ these are the factors on which Reynolds number depends: rho, v, d and eta. So d is nothing but dimension of the pipe, v is nothing but velocity or speed of the flow of liquid, okay, fluid, rho is the density of the fluid, then eta is nothing but viscosity. Okay, now there is a condition. If the Reynolds number value is less than 1000, then we say that the flow is streamline, okay, or we say the shallow flow. Howdalva? Now if the value is greater than 2000, then the flow is turbulent. See, if the value of Reynolds number is less than 1000, then the flow is streamline. If it is greater than 2000, it is turbulent. What about in between? In between, the flow is unsteady. We call this flow is nothing but unsteady. That means if the value of Reynolds number decreases, it will become streamline. If the value increases, then it will become turbulent. So on which factor does it depend? You can see here, consider velocity. Howdalva? Idella same irutte. If you consider particular liquid, if the velocity changes, what happens? This value is going to increase or it is going to decrease. Nimage artha agtide alva? Velocity ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. If the velocity is higher, then obviously the flow will be turbulent. If the velocity is lower, then the flow will be streamlined. Okay.